Okay, so in part A, we're asked to find the sum to infinity of this geometric series. Okay, so for the sum to infinity, we've got the formula here. We need A and we need R, yeah? Now, A is easy in this case. The first term is 40. Straight away, we can sort of identify that. R is also easy, because remember, to work out the common ratio, you just divide consecutive terms. So start with the term on the right here, and divide it by, so it's negative 24, yeah? And divide it by the term before it, 40. Or you could do 14.4 divided by negative 24. You'll come out with the same answer to be negative 0.6. Okay, so that's what R is. So the sum to infinity then will be 40 all over, okay, 1 minus 0.6, which works out to be 25. You put that into your calculator because that becomes a positive there, of course. Okay, so that's the sum to infinity when you add all these terms. Okay. And one thing to look out for here is that the common ratio should be a negative in this case, yeah? And the clue is that the signs keep changing, okay? Negative, positive, negative, because you're timesing by a negative common ratio. Okay, so B is a little bit of a tricky one, okay? But if you persevere with it, you'll get there, okay? So first of all, they tell you that T4 is equal to 8, okay, and then they say so the fourth term is equal to 8, and then they say that the third term and the fourth term and the fifth term, they add together to give 28. Now the key to making this a bit easier is realizing, because they've told you the fourth term is 8, substitute that in there straight away. So T3 plus 8 plus T5 is 28. Take that 8 over the other side, so you end up having T3 plus T5 is 20. Okay, so you take it over and subtract from there. So then you've got T4 is 8. So remember now, using the formula here, put 4 in. So AR to the 4 minus 1 will be AR cubed equals to 8. Okay, so that will be like equation 1. And then here then, T3 will be AR to the 3 minus 1, so that'll be AR squared. T5 will be AR to the 5 minus 1, so that'll be 4, equals 20. Okay. What I would do here with this, right, it's going to be difficult here, possibly, if you try to get A equals, okay. Even there you get A equals, it'd be 8 over R cubed. Wouldn't be particularly nice. So what we can do is divide, okay? When we've got two simultaneous equations, we can divide them. But perhaps before I call this equation 2, what I'll do here is I'll factorize out here common factor of AR squared, okay? That might make life a bit easier. So AR squared times 1 gives me this, and then I've got to times the AR squared by R squared to get you AR to the power 4. So that's equation 2. What I'll do then is, if I do equation 1 divided by equation 2, okay, right, so we often have to divide with GPs, so I'm choosing 1 divided by 2 because we've got the higher power of R there compared to the R squared here. So you have AR cubed in equation 1 divided by AR squared 1 plus R squared in equation 2 equals to 8 from equation 1 divided by 20. Okay, and what happens here nicely is that the A's cancel, okay, and the R squared there cancels with the R cubed. So you just left with R here, okay, because you take away the powers, so you just R on the top. So we've got R here over 1 plus R squared, and 8 over 20, okay, cancels down to be 2 over 5. Okay, simplifies down. So then take the 5 up here, so you've got 5R, and take the 1 plus R squared up here. So you end up having 5R is 2 plus 2R squared. So then 2R squared minus 5R plus 2 equals 0. Okay, and you've got what they want. Okay. So then, we've shown that it satisfies this. So we've answered part 1. Part 2 then says, given that R is less than 1, find the value of R and the corresponding value of A. So here then, we're going to factorize it. Okay, so we've got then this one is factorised. So then 2r minus 1 is 0, or r minus 2 is 0, so that means r equals a half, or r equals 2. But since r has got to be less than 1, okay, r then is going to be a half, right? Okay, so it can't be 2 in this case. So we've got to take the half value. And then once you've got half, we then can sub it back into 1 to get a. So remember now 1 was this formula, ar cubed equals 8, okay? So we can put a times 1/2 cubed equals 8. So that'll be a times 1/8 equals 8, which means then a will be 64, okay, when we take that 8 over to the side.